Okay, ladies and gentlemen, let's go ahead and finish up our additional operations. Now, we've already figured out that sometimes you can just simplify a radical and then go ahead and put it together to add. Here we have three pieces. You go ahead and simplify, simplify. Now they're all in like terms, and so by being in like terms, you can put them together. Here, because they're all multiplied, we can use the commutative property of multiplication to reorganize them, put them together, then simplify, makes it work out super duper nicely. So in this case, you end up with what you got? 8. 8 times 6 is 48. 48 times 5 would be 240. 240 root 3. There you go. So it works out fairly nicely. Now, down here, I still have something outside parentheses. Well, if I pause and go over here and I say, hey, wait a minute, if I have 6 outside x plus 2, all I really need to do is say, give the 6 away to each piece. 6 times x, 6x. 6 times 2 is 12. Well, same thing happens here. I have 6 times root 3 is root 18 plus root 6 times 2 root 5. I get 2 root 30. In which case, what I can try to do is I can try to break them up when possible. 2, 9, 3, 3. I end up with 3 root 2 because, again, I got a pair of 3, so that comes out front, but I got this 2 left over, has to stay underneath, plus, now, 30 is 3 and 10 and 2 and 5. I got no pairs. Everybody stays underneath. And there you go. That's the best I can come up with. I can't put them together because they are not like terms. Now, if I have something like this where I have a binomial times a binomial, I still need to give it away first times first. Root 9. Outer times outer plus 4 root 3. Inner times inner, 2 root 3. Now that's plus because they're different terms. And finally, last times last, 8. 4 root 3 and 2 root 3 together make 6 root 3. So 6 root 3, very good. Those two make 6 root 3. Now, 9 is 3, so what's 3 plus 8? That is 11. So you get 6 root 3 plus 11. Same thing's going to happen up here. Now, you'll notice everything in here is a root. So root 3 times root 5 is root 15. Root 3 times root 7 is plus root 21. Now, again, we're multiplying. That's why we can take the 3 and the 7. They're both under roots. We can put them together, okay? So you end up with that. So you end up with root 40 times 5. So I have root 200. And finally, root, oh my goodness, 280. Okay, so at this point, you try breaking it up. 3 and 5, nothing I can do. 3 and 7, nothing I can do. 200, well, 2 and 100, 2 and 50, 2 and 25, 5 and 5, so that works out. 2 and 140, 2 and 70, 2 and 35, 5 and 7. So in this case, I got a pair of 2s, a pair of 5s. So I get root 15 plus root 21, because I couldn't do a thing with them, plus 10 root 2, plus I got a pair of 2s, and that's all I got, 2 root 70. That's the best I can do. Okay, so again, operations, all the same rules apply. Whether these were x's or y's or square roots doesn't make a difference. All the same rules apply. So additional operations with roots.